There you are. Hey there, folks. I've decided that tonight I'm going to discuss 3 really cool science stories that I've read recently. I've been pigging out on Neil deGrasse Tyson's Inexplicable Universe series. Way better than the recent Cosmos crap. The shitty animation. Anyway, and so I'm in a science mood. And so here's 3 extremely cool science stories as I remember them. The first one is literally extremely cool. A group of scientists recently got a block of copper down to the coldest temperature ever. It was something like 0.0006 of a degree Celsius. That's the closest to absolute zero as we've ever gotten. And my feeling is that that absolute zero is one of those things like the speed of light, where you never actually get there. More on that later. So, yeah, they got the block of copper down to that cold, not just because it's an inherently super cool thing to do. Probably wouldn't exactly get them the funding, but also because by cooling it and keeping it locked away from all other forms of radiation, they hope to be able to detect radiation and heat. They hope to be able to detect some kinds of particles that we've never been able to detect before, and they detect them by measuring the extremely small amount of rise in temperature on this block of super cold copper. So it has a practical purpose as well. They've proven that they can not only get it down there, but they got it down there and kept it there for 15 days. And that should be more than enough, for experimental purposes to find these weird different particles. So there's that. Let's see. In keeping with the theme of the extremes of science, and specifically the speed of light that I just mentioned earlier, from Neil deGrasse Tyson, I learned a little bit of trippy particle physics. I'm telling you, man, astrophysics and particle physics and things like that, they are just, oh man, who needs drugs? Now, imagine this, right? And sorry for the people who I've already told this, but it's just too cool. Imagine, as we all know, the closer you get to the speed of light, the slower time goes. It's called time dilation. And this is true even for really, 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 really close to the speed of light. So it follows that if something, it follows that if something is actually going at the speed of light, time stands still. Time becomes zero. So that means that from the point of view of a photon, elementary particle of light, obviously it moves at the speed of light, for it, time does not exist. There is no time. There is no time elapse between when it is emitted and when it is absorbed by something. Its entire lifespan happens in zero time. For a photon, there's no such thing as time. Now, obviously for us, observing the photon, we can see it moving at the speed of light, right? It would take a year to go a light year and all that. But from the point of view of the photon, nothing has ever changed, or nothing has ever happened. It was emitted and absorbed as close to simultaneously as exists in the universe. Arguably, it is simultaneous, except from certain frames of reference. Now, isn't that fun to think about? Light, which is all around us, for light, there is no time. And finally, one that I just read about today has to do with light's slower, less cool cousin, sound. Researchers have found a way to use ultrasound, which is ultra-high frequency sound, to actually temporarily disrupt the blood-brain barrier. Now, the blood-brain barrier is this coating that neurons have that essentially makes sure that only certain molecules, like water or sugar or proteins, basic proteins, things like that, actually make it into the brain, instead of just circulating around inside the arteries in the vein. Now, this is great because it keeps a lot of nasty stuff out of our brains. But it also means that it's extremely hard to target things in the brain with large molecules that won't go through the membrane. The blood-brain barrier is actually a big hindrance to a lot of forms of chemical brain therapy, basically. And so they figured out that with by implanting these ultrasound emitters at various points in the skull, they can disrupt that barrier enough, and for a short enough time, about 48 hours, that they could get these large molecules into the brain where they can do a lot of good. One thing that would be especially great for that is that they would have to use a lot less of certain harsh drugs like chemotherapy drugs, where at most 2% of the dose that you give the person actually ends up in the tumor, and the rest is just hanging around giving them side effects. So if you could reduce the dosage of chemotherapy and other neuropathic drugs and things like that, that would be worth it right there. You know? Radiation, maybe. And so, well, you know, we can't just ignore the fact that disrupting the blood-brain barrier is a serious fucking thing to do. So, those 48 hours, the person is probably not going to go home and you know, stuff their face with Taco Bell. They'll stay in the hospital, and they'll be very carefully monitored, you know, what goes in and what comes out, to make sure that only the thing that we want getting through the blood-brain barrier gets through. But given the potential benefits, that seems worth it. I'm sure an awful lot of people who have brain cancers would rather spend 2 days in the hospital being monitored, but only getting 1/50th the dose of the chemo drugs, than getting the chemo, having to stay in the hospital and be monitored anyway, and feel like death. Feel the worst people ever feel, from what I understand. So, those are the 3 cool science stories. I tell you, science never fails to just make me excited about the future. There is so much lying ahead of us if we can just make it there. Well, that's all for me for tonight, folks. I will talk to you again tomorrow. Bye-bye.